to Argo Unpacked. All right, catastrophic downtime when AI agent guardrails fail, and Dr. Argo is in the house to talk custom resource health checks. Plus, we take community questions, all on today's episode of Argo Unpacked. Let's get ready to unpack. So hope you're settled in. You got your soda, you got your coffee, you got whatever. You got some popcorn, because it's about to get wild in here. Make sure to tell your friends, like, subscribe, share this with all the folks who need operations excellence, GitOps guru greatness, all coming up on Argo Unpacked. But first, we got to hear Tip of the Week. Okay, this week's tip is all about telling agents what not to do. Okay, the tip succinctly is this: telling agents not to do something is not a guardrail. So this is a story that was going viral on Twitter. And oh, sorry, let me pull it up. Oh man, I mucked it up. All right, here we are. So this is a story that was going viral this week about an AI agent that destroyed production data, and it even wrote its own confession. Now, this story basically boils down, I'll run it succinctly, but we'll post it in the show notes and you can read the whole thing. It's a great story. Basically, the agent was working on a task where it figured out that there was some kind of credential mismatch on a database, and it decided that the best way to solve that credential mismatch was to delete the database, to delete the volume that the database was actually running on. And of course, the agent guardrails didn't allow it to do this. It didn't have access. It didn't have access via its tokens that it was given to do this operation. But it did know that within the code base and the secrets it had access to, it did have access to a token that could do this. So it took advantage of that token and it went ahead and deleted the volume. Now, it turns out that Railway, the service provider, that the default backup strategy is to take database snapshots on the same volume where the database is stored. Does anybody see where this is going? Well, it deleted the volume. And it turns out that that token, which was not created for the purpose of handling volumes, happens to have basically global root access on Railway. And this is a limitation of the Railway platform. And so it led to not only the database being deleted, but the entire volume, which contained all the database snapshots, which meant they lost 3 months of customer data. Now, as of today, it was over 72 hours. Railway did come up with a recovery for the lost data. They did come back with it through some external process, and it became this emergency thing and it blew up. But in the letter, I'm not going to read the inappropriate words here, but there is, the agent actually wrote that it has 2 rules: never guess, and the other one is never run destructive or irreversible Git commands unless the user explicitly requests them. So there's this thing that people do with agents where they tell it not to do things, and then the agent does that thing, and they're surprised. And so the Argo tip is that, and this is what I wrote as a tweet, and I have a feeling this is going to be evergreen, and I'm going to be able to reshare this over and over again. Telling agents not to do something is not a guardrail. Now think about this, like put on your human hat for a second, if you have one, and ask yourself, what's the best way to get yourself or someone not to do something? Like, don't think of that song, it'll get stuck in your head. What do you immediately do? You think of that song. Well, agents work entirely off of context, right? And so if you tell it in the context, don't do something, in a way, it's almost like you're suggesting to the agent that they should do that thing. It's like when you're driving down the street and a deer jumps in the road and you're like, don't hit the deer. And you stare at the deer and your body starts to steer towards the deer. And then you hit the deer because you can't look at anything other than the thing you're not supposed to hit. Telling agents not to do something is kind of a way of telling agents to obsess about doing something. So if you think that that's a guardrail, you're wrong. Telling agents not to do something is not a guardrail. It, in fact, is oftentimes a creation of fixation on agents. Now, why does this matter when it comes to Argo? Well, how should operations tasks be done? Folks, you're all going to be saying it at home with me via Git. They should be done by Git, right? The whole point of GitOps is that you make a commit. That's how the operations should be completed. And so you can imagine that if this agent had tried to open up a pull request that had deleting the database and explained its rationale, and even if that PR was reviewed by another agent, the likelihood that it's merged and that it goes and deletes the database is low. It would probably not accept that, especially if you're using Git as the interface for changes. This is the kind of incident that would be avoided entirely. Now, in this case, they were able to eventually get the data back, but it meant that in this provider that went through this provides software to rental companies, rental agencies. And so there were about 3 days where people were showing up for car reservations and they had no record that they had reserved the car. They had to go back and try to restore some of these entries using manual forensics inside of Stripe to figure out what transactions had occurred. Real nightmare. Feel bad for this company as well as all their customers who had to go through this. And obviously, hey, if you're working on the bleeding edge, sometimes you're going to bleed. So it's a little dangerous. So that is the Argo tip of the week, is telling agents not to do something is not a guardrail. Get permissions, tokens. Be aware that if you have tokens available to the agent, even if it's not told to use those tokens, agents are clever. They'll figure out, hey, if I want to do something, if I have access to find that token somewhere in my code base, somewhere in my context, somewhere in the things I have permission to, I'll find that thing and I'll use it, and I'll go do the task that I think I'm supposed to do, even if I have been told expressly not to do that. So that's first up. Now let me introduce our guests. Argo Unpacked special guests. Okay, this week we have, in addition to Ravital, our producer and co-host, thank you, Ravital, for joining us, we have the amazing Reggie Voloshin, actually first time on the show, even though she is the #1 Argo maintainer and just basically leads the entire Argo contributions from the Octopus Deploy team, sitting next to Ravital. And then we're also bringing in Dag, also first time on the show. And Dag has been a fixture also in ArgoCon, has contributed a lot of cool work with diffing and been a pillar in the community as well. So welcome to the show, Dag, Reggie, Ravital. Glad to have you all.
Thank you so much. Glad to be here.
That was good. Synchronized head bob and everything. All of you nodded at the same time. That was cool. So before we get into the next topic, which we're going to be talking about, custom resource health checks, and some of the really interesting nuances about that inside of Argo. Any reaction to the tip of the week? Telling agents not to do things is not a guardrail.
Yes, I first of all have to admit that's the way I do it. I have added guardrails that is basically just me telling it not to do something, and the reason I've done that is, well, I thought it was kind of annoying to keep like whitelisting things that it was allowed to do, and over again having to add those special rules, and then they broke and I need to update it and so on. And I ended up changing it just to say, do whatever you want, but don't do any destructive actions. So far, it usually works. Sometimes it pushes to something it shouldn't push, but currently I still think it's worth it. But eventually there will be a day where I regret this decision, I believe. So I will definitely read this article.
Well, this is the reason that this rule sits here is not because this is the first incident of it doing something it's been told not to do. We've all had the experience personally of agents doing things we told it not to do. I even heard one just yesterday where somebody had set up essentially an autonomous company was the experiment. And one of the things they said is, hey, don't go and create GitHub issues. Keep all discussion internal to this thing. And within a week, it was out there posting GitHub issues and interacting in the community. And it was like that was where the guardrails that we put in place. We told it not to do this thing. But if an agent can do something, it eventually will do that thing if it fits within the guideline parameter of its mission. And its mission can be quite broad. I mean, this is the paperclip problem. We saw this with Claude actually shared an internal example where they had told agents to kind of maximize for building revenue, and the agent interpreted this to mean that it should hack its own nodes, take those over, and then reallocate the GPUs from running the agent to mining Bitcoin. And it turns out basically it's just shutting off parts of its brain in order to mine Bitcoin, if you think about it, which is pretty wild. What do you think, Reggie?
I think that it reminds me.
Oh, you're really quiet. Sorry.
Am I? Okay. So this reminds me of another incident that took place a couple of months ago, where the agent did not only delete the content of the database, but also lied about doing that and filled the database with random data to cover for itself.
That's even better. That's like me finding my toddler and I'm like, did you do this? And he's like, no. It's like, really? Like somebody else got out the peanut butter and poured it all over yourself? No, I didn't do that. Oh, okay. Somebody else did it. What do you think, Ravital? You've been in the AI space longer than all of us in this room combined.
Yeah, but I have to say, one thing I was super curious about. Your story about the deer was so detailed. Did you ever hit a deer?
No, I've never hit a deer. I've never hit a deer, but when I teach my kids driving, one of the things I talk a lot about with them is fixation, and like how like where you look is where you go, right? So like when you learn how to drive, when you're turning, the default for most people is like they look at the edge of the road that they're turning away from, and that makes your body drive towards it more, right? And so telling them, hey, like in the turn, you're supposed to be looking through the turn where you're going to, and your body will naturally start steering you there. You know, that's like,
yeah, same
repeated.
Yeah, same experience with bicycles. Yeah. Okay.
Yeah. Don't worry, I haven't hit any deer with a car. Like, I don't want to get too specific. Okay.
Yeah. No need.
Okay. So, Ravital, let's move into our topic of health checks, and why don't you set that up for us?
Okay. So Reggie and Doug, thanks for joining us. We will be diving into a super interesting topic, which is the GitOps manifest dilemma. There are so many tools, so many templating tools for Kubernetes deployments out there. And I would like to start with you, Doug. Which ones are the best? I know that you did a lot of research in that domain. So
surely there's one right answer.
Exactly. I think people are definitely going to have different opinions here. I have probably changed my opinion a bit on this over the years, but unfortunately, I always come back to Helm as the best option. And that's not because it's actually very nice to work with or anything else, but the rest of the options just have too many other downsides to them, meaning I usually find it more easy to just go back to Helm every single time. But that doesn't mean it should stop you from actually trying all the other tools, because there's a lot of hype tools out there that are going in cool directions. But currently, I just feel like a lot of them has too many drawbacks to actually pursue that one in your company.
The worst thing about Helm is that everybody uses it poorly. And so like you get a third-party Helm chart and it is very poorly constructed, right? And then you consume it maybe in the wrong way because you're sticking it inside of, you're just referencing it with an Argo app and you're just throwing in parameter overrides. So you're doing it wrong there. And then like you need to change something that the Helm, the maintainer of that thing didn't plan for, and there's no option to do it. So like in a perfect world where people made perfect Helm charts and people consumed them perfectly, Helm's amazing. And by the way, I'm trashing Helm. I want to show you something. Here, look at this. Hang on. This is no joke. Okay. This is a special thing that was given to people who helped make Helm 2 happen. Okay, moving from Helm 1 to Helm 2. And I participated in the Helm Summit, and I was gifted this as like, hey, you helped with Helm. Good job. So I spent a lot of time trash talking Helm, but I want you to know I participated in that project too. And it's not because Helm is great. It's fantastic. It's just that everybody kind of sucks at using it. And that makes the experience as a user miserable because people make crappy Helm charts. But it's not the fault of Helm that is.
Is it on purpose that it's like tilted inside the frame, or?
Yeah, it's kind of, it's
it's
around.
loose.
It's jostled. I get it out
Sure.
too often, and I carry it around too much.
And I have to say, go to our YouTube channel, Argo Unpacked. There are so many tips that Dan provides about how to use it the right way. What are the common mistakes and how you can actually avoid them. So go to those tips, listen carefully.
Yeah, the last one on Helm Sandwich. And I'll have another one for you this week, Rivitel. So stay tuned, folks. There's more coming. But anyway, off topic. Dag, sorry, get us back on topic. Save us.
Okay, I'll try. So going back to the whole manifest dilemma topic, yes, I did last year a lot of research looking into the different kind of options there is for building our templates and rendering all our manifest and so on. Because in our case, I think it's many companies are going through this. They're like, my team had to figure out what is the best templating options for our company. We are maybe a little special in our case because we have like the company I work for is called Egmont, and we own a lot of other companies that we don't necessarily have a very close contact with. So it's important that we have a very nice and clear interface between the other companies and what infrastructure we are exposing to them and so on. So I was trying like seeing, okay, should we go with a trusted Helm or Kustomize or something like that? Or should we try like Crow or Crossplane or some of the other tools for this kind of templating mechanism? And we tried doing a little demo of all of them and seeing how it felt and so on. And then to me, it just felt like many of the other options ended up having too many drawbacks of using it. And let me give you an example. So for example, Crossplane and Crow, those tools are getting a lot of hype at the conferences, and they are very cool in their respective ways. But in a GitOps world, I feel like they fall short in a few different ways. For example, it can be very difficult to do any kind of local rendering when you're rendering your templates. So for example, with Kustomize and Helm, it's super simple. You can just write the CLI command, you get an output, and you have evaluated it. Very easy to do. But when you're using, for example, like Crow, well, Crow does not have this feature currently, so you cannot do this. You just have to apply it to a cluster and pray that things actually turn out the way you expect. I'll give them some slack here. It's a new project, so I hope that eventually there will be some kind of functionality to test this. But even with Crossplane, it can also be kind of a challenge because Crossplane, you can do the local rendering of your templates, but it requires so many extra steps, and you need to have a container runtime installed to even like mimic the functionality of running a Kubernetes cluster locally and all these kind of things. It just means that the whole experience slows down and it's harder to do. And I think this is a big like challenge here because it means that we have to like merge and just pray and hope that things actually turn out the way you expect.
I'm glad you brought that up actually, because that was the original fifth GitOps principle. Everybody knows there's 4 principles, but the original 5th principle was apply manifest should be prayed over so that you get the optimal result. And we ended up deciding not to do that because it didn't feel like it was idempotent enough and predictive enough to just say pray that the manifests render the way you want them to. That's
fair. But I personally think that that's definitely one of the biggest drawbacks here. We don't want to, especially when you upgrade components in like super critical components in production and so on. Like I don't want to risk like merging these kind of things and just hoping it works. And yes, you can of course try to mimic your production environment in a testing environment, but like, come on, it's not exactly the same. So I would not risk it.
This is the biggest drawback of application sets, right? Is like you can render application sets locally now, which is a great feature that we added in the last year. But even when you've done that, you then have to go and render each application that you have now modified with that application set. So it's not trivial to do that, and it can be a little scary sometimes. So at least you have like maybe a staging environment to do that, but it gets definitely more complicated with something like Crossplane, where it's like, hey, I'm changing something that's going to literally go and apply AWS resources and spin up a new cluster or create new volumes. And it's like, okay, well, ooh, like I kind of want to preview that. That's where like Terraform, you had like Atlantis, right? Which was like, oh, I'm going to get a nice summary of exactly everything that's going to change. I can look at a pull request. That's not where you're going, I don't think. But like, I don't think for Crossplane, there is really an equivalent out there today. Is there?
I don't think so, but I'm not only talking about like the managed resources of Crossplane, all those that you sync with the cloud provider. I'm also thinking about Crossplane compositions, which is their specific feature for just doing raw templating, like the same thing that Crow has, and even there it's a challenge, even when you don't have any external dependencies. So yeah. Besides that, I of course also have other kind of challenges with these kind of tools, and that is also when it comes into to health checks, and that is so. How to say this? When you are building these, okay, maybe it's helpful to viewers for those of you that may not have used Crow or Crossplane compositions before. It's basically this idea that you're writing a custom resource that you can fill in, and based on this custom resource, that will then generate the resources you need. So, for example, if I was a platform developer, I could create some kind, or a platform engineer thing. I could create a custom resource called a website, and when a developer defines a website, they will then create something like a deployment, an ingress resource, and a service, config map, and so on, like as a package. But whenever you do this, you need to ensure that the status of this so-called website that you have created is correctly being updated, the status of that based on the underlying resources. You're basically building an operator here that is kind of like propagating that information up into the custom resource, and that becomes very complicated quickly. Even if you're using something like Crow or Crossplane that has this kind of feature built into it, it's still a lot of work that you have to maintain, and you have to trust that your actual health checks that you built into the template actually works. And that is just a lot of work and a lot of pressure to put on yourself, and especially because we have so many other tools that rely on these health checks. For example, Argo CD is checking various status codes, and for your custom resource that you just developed, well, Argo CD does not have a built-in health check for your homegrown custom resource. So you need to kind of like override health checks and all this kind of stuff. And it just very quickly becomes a lot of work.
Yeah, this is that's an issue like we see a lot with Crossplane compositions, where like there is a default health check for composition, but depending on what you're composing, it may be completely inadequate, because it's like, hey, the ingress has been applied. Like, can it be reached by network? And it's like, I don't know. Like, it's been applied to Kubernetes cluster. What do you want from me? Whoa, you want it to work? Wait, you didn't ask me to do that. You just asked me to apply the manifest. How am I supposed to know if the thing actually works? And for Argo CD users, they do get a leg up on this, because we actually do have a huge library of custom health checks that are baked into Argo CD. We had a whole debate about if this was something that we should actually try to push into Kubernetes upstream, because Kubernetes doesn't really deal in the health. It only specific resources have health checks built into them, right? Like deployments and things like that. And unless you write your own. So it was like, is this something that we could generalize to just be a Kubernetes problem? Because ultimately you want to know if the thing is deployed correctly. And we kind of felt like it would be really difficult to generalize. And it was actually a really big advantage to using Argo CD anyway, that we have these things built in. So maybe a limitation that's worth it for the users.
For sure. I think there's plenty of options to actually kind of streamline this across the ecosystem. It seems like this has not really been solved at all. And there's it feels like there's many people complaining about it or writing like issues that this is kind of a problem overall. And it seems like every time you find a new tool, they are interpreting, for example, the status of ready differently. Like it's not a general term. And I am always wondering, like, what does ready even mean in whatever context? For example, I think something like even something simple as a deployment, people would define that as ready in many different ways. For example, does it mean that it's all the pods are available, or does it also mean that it's on a newest version, or can it be like degraded? What does ready actually mean?
Or are
And
the services on the pod actually even ready to serve versus like the default is like, hey, the pod has started, so it's marked as ready and it starts receiving traffic. You have to add in an additional health check to say like, no, I'm going to check this specific port to see if it's serving the thing I'm expecting. Like that's something you have to write. And a lot of people don't, they skip it. And then they're like, hey, we don't have 0 downtime updates. Why is that happening? It's like, well, because you didn't tell it. You didn't tell it that you needed this service to actually be running. You said the pod had to be running. Well, it turns out it takes 45 seconds for the service to start. Or maybe there's a bug where it's broken. And so it's going to say it's ready and it'll just be constantly restarting, even though, that's such a key element of like good operations is to have these health checks. And it's definitely way more complex when you're using custom resources.
For sure.
And that, so do you have any personal rule of thumb on how to pick a template tool?
Yes. I think, can you share my screen or can put in something?
Yeah, you got it.
I have some slides here that I had for KubeCon. Let me see if I can find something.
You also had a great session in KubeCon.
Thank you so much.
Yeah, we'll throw that in the show description. Definitely go watch Dag's full talk on this topic.
But we can do a quick little run through right now with a few of the slides here, which I think is the most important one. But as I see it, I think you can take most of the tools and then you can split it up into 2 different categories. We have like the out of cluster rendering tools, which is Helm and Kustomize and all these things that are basically just a CLI tool. And then we have like Crow and Crossplane, which is these that are running inside Kubernetes as an operator. And I think we can split them into even, in this case, split them into 3 steps instead, or 3 categories. We have those that are out of cluster rendering. That's what I call it, just-in-time rendering, where we have something like Helm and we have Kustomize, and that can be read by your GitOps operator directly, either Argo CD or Flux, and then it just does all the rendering locally inside the tool itself, and then applies it directly into the Kube API server, and then you're done. So in this case, like all the rendering is happening inside the GitOps operator, and it's very simple to work with and very easy for new users to both Argo CD and Flux and tools like that. But when you start switching to these in-cluster rendering tools like Crossplane and Crow, well, suddenly you have now moved all the rendering capabilities into what I call a templating operator. So instead of letting Argo CD and Flux do the actual rendering and applying it to the Kube API, you have now moved all the rendering to a second step. So you apply the custom resources to Kube API server, and then the templating operator kind of reads those and then generates other resources. So now you have, like, this is why you cannot see the actual preview anytime before it hits the cluster, because the templating operator needs to pick up these kind of resources in order for it to actually work. But there's also a third
way, not to derail you, but Flux is probably a little bit more like a templating operator because it does things like Helm lookups, right? You apply, like, you have a customization, like a Fluxtomization that is actually like an entity that lives cluster side in a way that Argo CD doesn't do. Like Argo CD renders all manifest without talking to the cluster. It's all separate. But it doesn't diminish your point. I just don't want to make sure that I don't want the Flux people coming back in our comments and yelling at us later, but that's all.
No, thank you. Yes, there's details to this depending on how you mix which tools together and so on, for sure. This is more, overall so simplified. Yeah, and then we also have the rendered manifest pattern, which was also fairly popular a few years ago, at least when it was introduced. I still think a lot of people use it. But this is where you can introduce even more types of rendering tools. For example, I picked in this case Pickle, which is the language from Apple, and the CDK8S, which is this language where you can write your YAML in basically any kind of language. So if you wanted to do it in Python, for example, you can write your deployments in Python with all the looping mechanisms and so on. But these tools are something that is not supported directly by your GitOps operator. It's not like these tools are a different project. They are not directly integrated into Argo, for example. So in this case, you would have to like pre-render your manifest in this case. So you have like a Git repository where you have your configuration in these various tools you're using, and then you are pre-rendering everything with the CLI and storing it somewhere else in Git. And from that point in Git, it is fully rendered, and Argo CD can just pick up the resources and apply it directly to the Kube API server. So in this case, you have shifted all the rendering mechanisms to Git, and then you can also validate all your code before it goes into the cluster and so on. But this, as you can probably guess, requires way more automation compared to the first version here, which is where you only have a single Git repository. And
But I don't want to get yelled at that people are going to say, hey, Argo CD does have rendered manifests. You can use config management plugins to run all that stuff and have it committed to Git. Totally doesn't change the point. The point is you're getting it fully rendered into Git somehow.
Yes. That's basically the separations I'm using. I'm using these three ones where we have out of cluster rendering, we have the in cluster rendering, and then we have like this rendered manifest pattern. And depending on which you pick, it has like pros and cons associated with it. Yeah, that's basically it. And the problem I was mentioning before was that like when you are using something like a templating operator like Crossplane or Crow, well, you suddenly have to be the one in charge of actually propagating this information of a failing deployment into the custom resource and then give it up to Argo CD in order for it to actually detect it's broken. So to achieve something that we like this is a screenshot for the, sorry, I need to remember that the listeners on Spotify may not be able to see this. So what you're seeing here on the screen is basically just a screenshot from Argo CD, where we can see that if you have a failing pod inside a deployment, it can be quite difficult for you to figure out how to get that broken pod status code propagated up into the deployment and into your website that I mentioned before, and then further up into Argo CD's health check system. And that requires that you both write custom code inside your in-cluster rendering tool like Crow or Crossplane, and you also need to write custom code for Argo CD to detect this website here. I don't have any code examples for it right here. Yeah,
but it's essentially it's like a bubbling problem, right? It's like if this pod is properly marked as failing, that should mark the deployment as failing, which should mark the composition as failing, the Crossplane composition as failing, which should mark the application itself as being degraded. And each of those steps, some of them you get for free in between them, right? But not all of them. Like you have to actually care about each of those layers. And a lot of us, hey, we write the app so that it deploys and everything turns green, and we reach the API and it works. And we're like, great. And then we stop there and we just assume it's done. But if we don't actually account for the failure conditions, you're going to end up with downtime where everything is green, and you're going to be bummed. You're going to be sad.
Exactly. And what I realized was that I was just surprised on how much time I ended up spending on trying to connect all these things and actually be in charge of ensuring that there's no health checks that accidentally was showing it as green, even though it was not, and so on. It was just way too much work. And I'm like, at what gain? What are we actually gaining from switching to this kind of paradigm compared to just doing good old Helm in this case, and let you be able to re-render everything before going into the cluster. And you're also getting this nice functionality that, like, to me, when I was first learning Kubernetes to begin with, and also Argo CD, it was amazing to, of course, open up the UI for Argo CD, like actually be able to see what will be deployed before it actually gets deployed. Like before you turn on autosync and everything, then you can see everything as these like yellow boxes, right? But the problem is that if you use something like Crow or Crossplane, well, in that case, you cannot see anything. You can just see that the custom resource, in this case, the website, would be created, and you would not know if any of the underlying resources would be created correctly or if it would simply fail the moment you click sync. And I think that's a huge downside, especially for new developers that are not used to how this works and so on. So using something like Crossplane Kustomize or Helm really helps developers in these early phases actually see what's being rendered before it actually applies it to the cluster, which I think is an amazing feature.
So if we were going to break down the problem, we would say that like problem number one is, can I get the manifest that will actually be applied? And in the case of something like Crossplane, that's obviously more complex. Anything that relies on sort of server-side rendering becomes complex to get that thing. Then once I have that thing, can I diff it effectively and know exactly what will change? And then third, once I apply it, will I know if it's actually succeeded? Do I have the right health checks to do it? So it's kind of, the problem is the scope of making changes difficult to preview, difficult to know if it's actually working. And so to solve this, making sure you have really good health checks is number one, but then because that's going to apply no matter which of these routes you go into. And then if you can do it locally rendered, that's the ideal, because then you get to have your cake and eat it too, essentially. Let's actually pull in this question that Standard just asked. Dag, did you ever get Crossplane resources to show up in Argo CD, especially for Crossplane V1?
Did you ever get Crossplane resources to show up? Like the resources that has been generated from the actual custom resources that you created? I don't know how responsive this comment section is in terms of getting follow-up questions here. But I have not. I don't remember trying it with V1. When I did the last experimentation with it last summer, we did the V2, and we could see all the resources correctly being spun up with the whole like graph scene shown in Argo CD. So at least with V2, it works fine. I don't remember if it works with the V1.
Yeah, as long as they have, yeah, he's saying, oh, sorry. Yes, the child resources generated from compositions as, so in V1, they wouldn't show up by default, I think is what he's saying. Because I think in V2, they do show up as long as the composition is being tracked by Argo CD. Am I wrong about that?
I don't know.
But yours show up, Dag. You didn't have to do anything special.
No, but I was also V2.
I've worked with Crossplane V1, and right now I'm talking about basically working with Crossplane for managing cloud resources and not for managing Kubernetes deployments. But yeah, I've seen in the Argo CD UI the managed resources, which are basically the resources that Crossplane has created from the compositions, if that answers the question.
Yeah, if you have, I mean, anything, okay, let's put it this way. Anything that has the Argo CD tracking method on it will show up in Argo CD. So as long as you can get the default tracking method, I think, is annotation now. Or maybe it's label plus annotation. I think it's just annotation. So if you just add those annotations, and you can actually, they're predictive. So you can actually add them to any of those custom resources, and they would show up as part of the application. Usually you don't need to manually add those at all. That's just something that Argo CD handles by default. But that's ultimately, like, that's what's making the tracking happening. So even if you're stuck on V1, if you can find a way to get those annotations, assuming that your annotation method is, that your tracking method is set to annotations, it would show up. So yeah, something to think about.
Dan, you mentioned that we should write good custom health checks. So I would like to ask you, Reggie, maybe let's start with what are those health checks and why they're so important for Argo CD? And then if you can maybe list some best practices on how to write good ones for Argo CD?
Yes, of course. So I hope I can be heard well.
Yeah.
So yeah, basically we have already discussed some of the things that are related to the health checks. But basically the goal for them is to have us have the visibility on the actual health status of the Kubernetes resources. And I'm now talking at the Kubernetes level. I'm not even talking about Argo CD, right? So I would like to know whether my resource that I've just deployed is healthy or not. And I'm right now even not talking about Argo CD. And so the problem is, as it was already discussed, and I would like to stress some things, is that there are different answers to the question whether my resource is actually healthy or not. And even if I'm talking, about resources like basic Kubernetes resources like pod or stateful set or deployment, so the status of those resources, it actually looks different. And when I'm looking at a health status of one pod, then I know how to look and to interpret the health status of any pod. And the same goes for deployments, for example, and for stateful sets. Once I've seen one, I've kind of almost seen them all, so it's easy for me to interpret. And if I'm talking about the Argo CD level, then we need those health checks, one for visibility, and I'm talking about user visibility. I want to look at the UI, and I want to, from one glance, I want to know what happened to my deployment. But I also need it to bubble up, as we said, because sometimes with Argo CD, I'm using sync waves. And then it's very important for me to be able to carry on to the next sync wave only if the first wave completed successfully, meaning if it is healthy. Or if I'm using application set with progressive syncs, which is also something that is gradual, and each step is based on the fact that the previous step was finished correctly, meaning its resources are in a healthy state. And like we said, the answer to the question, what is healthy? Those answers are very different for every resource that we're dealing with. And currently, we have to teach Argo CD about how to interpret those different health statuses for custom resources, because for custom resources, there is no schema. It is not structured. So basically, it's up to every author of every custom resource definition how they surface the actual status of their resources. And it means that Argo CD cannot just have this knowledge on its own. So it means that Argo CD has to be taught how to interpret those custom resources. And this is the reason why currently we have so many contributions in this area. And if we're talking about best practices for how to write good contributions in the health check area, then I have a couple of tips to share with you. So the first thing that you need to know is that this area of providing health checks, it is designed in Lua. And the reason that it's designed in Lua is because in Lua, it is very, very easy to make something pluggable. And a custom health check script basically needs to be written in Lua. And it has to come with certain tests. It means that you will have to provide real Kubernetes manifests. I'm talking about live manifests, which actually have the status field. And you will have to provide that along with the actual logic of the script that calculates this health check in Lua. And another thing that is very important, and I'm not sure that many people are aware of it, but there is a special field in the Kubernetes status that is called observed generation field. And this field is important because and I will take the example of Argo rollouts, because it's a very popular project. And if I'm now editing a rollout, meaning I'm performing a rollout, then my custom resource of a rollout would go and change. It changed, but if I'm looking at that resource, I don't necessarily know whether the Argo rollouts controller already responded to that change and performed the actual step. Or maybe I'm looking at a health status that it's actually stale, because maybe the controller hasn't picked up the change yet. So the observed generation field is actually the field which I can use in order to determine whether the status that I'm looking at is actually stale or relevant. So if my observed generation is equal to the generation field, then I know that the controller finished reconciling the change that I have asked it to reconcile. And I need to say that whether the observed generation field is used or not used in the CRD, the only person who controls that is the author of the custom resource definition and the author of the controller. So as a user, I can rely on it when I write my health check only if it is actually used. So the first thing that I would like to ask you when you contribute a custom health check is to carefully look at the live manifest and to see whether there is this observed generation field. And then if it is there, please use it in order to determine the correct status of the resource. So this is tip number one. The other thing is that we have health checks that are wildcarded. And speaking of Crossplane, this is very relevant for Crossplane because many of those statuses, many of those conditions are actually common and repeat themselves among the different resources of Crossplane. And so in Argo CD, you can contribute a wildcarded health check, which means that this health check can be used either for many kinds for the same resource group or even for multiple sub-resource groups. So please be minded to that and try not to write checks that are repetitive, but instead, if it is possible, try to generalize them and use those wildcard checks. Another thing is to search for the project documentation. I know that mostly this information is not available at the project docs, and I'm talking about the structure of the status field. But sometimes there are certain status condition types that are documented, and if you're basing off documentation, then definitely it's going to be much easier to write a health check that is covering a better range of use cases. But again, most of the times it is not documented, but it's worth checking in the source code of that particular project, of that particular custom resource that you are writing the health check for. And probably my last tip for good custom health check is try to cover like the maximum number of cases that you can observe in your environment. Because essentially, if you're not the custom resource definition author, then your knowledge and your observation of the health check is more or less limited to the particular use case in your environment. And so if you try to observe many different cases, I don't know, many different types of errors, progressing state, etc., then your health check will be more complete and will be able to actually benefit a larger amount of use cases and amount of people.
Yeah, those are great pieces of advice. And I know that writing Lua scripts is none of us wake up in the morning and are like, man, you know what I'm jonesing for? Just write some Lua scripts. I think it's kind of funny because it's like we say Lua scripts as if everybody knows what they are. I think most people don't know what Lua is. And that is what it just is what it is. But Lua scripts aren't that hard or complex, and there are a billion examples. And honestly, I think that this is something that AI is probably pretty good at. So you can just tell AI to write a Lua script for you, and odds are pretty good that it's going to come out with something reasonable to work with. But yeah, without these health checks, it's just impossible to know what's actually happening. So these are great tips, Reggie. Coming straight from the #1 Argo CD maintainer over here, Reggie Bulletin, telling us how it should be done. And we do get a lot of contributions on Argo project around Lua scripts. And to be honest, when I review those contributions, I'm basically like, did somebody put a backdoor in here? Nope. Have I used this random Azure resource that they're talking about? Nope. But it looks reasonable and it doesn't have any security issues in it. And whoever's submitting it seems to have thought that this works. So by all means, if you want to submit those health checks, you have pretty good odds of getting them accepted in the Argo project.
Dan, actually, this resonates a lot with the question that you've touched upon earlier. And actually, this is an excellent question, an excellent discussion about whether those custom resource health checks even belong in Argo CD. So I've looked up at some of the Git statistics, and I saw that last year we had around 30 contributions around the custom health checks. Mm-hmm. Overall, we have about 240 or something custom health checks. And in spite of that, I will give a controversial opinion that I think those health checks do not belong in Argo CD.
And, they should be part of the CRD, right? The CRD should have its own health checks baked into it, right? So when you install the CRD, it says how the health should be monitored. And then Kubernetes should be able to report that status, or at least track it or update it. And then Argo CD should just be able to consume it. That would be the ideal.
Yes.
If we could wave a magic wand and get everybody to get on board with it.
Can I ask, how would you do that? Like, what would you expect the CRD then to expose to the user, or what should you be enforced to add in your CRD?
Lua scripts.
Okay, great.
honestly, the answer is probably Lua scripts is the answer. But like, if you took like the entire huge database of these that Argo CD has developed, and you said like, okay, CRDs as a standard, to be fully compliant with like whatever the next version is, you need to have defined health checks in here. The only challenge is that the health checks that are written for Argo CD tell you specifically the status of an application, right, as being progressing or degraded or whatever, which is a group definition that applies specifically to the custom resource of applications in Argo CD. And that's not a concept that exists inside of Kubernetes. And so it would require a level of opinion that is probably not going to happen in the Kubernetes community, unfortunately, because it's too opinionated for what it actually needs to be applied.
I think it's not only a matter of opinion. You know, if we think about it, if now the CRD suddenly had like a typed a schema definition of how the status field should look like, it would actually be a breaking change for many of those controllers.
Mhm.
And the Kubernetes custom resource definition API, it's stable for ages. So this is something that's, I mean, it's practically impossible to enforce, but I see a couple of ways how can this be either standardized or like made a standalone common project for Argo CD. I mean, well, that's the thing. I don't see it as something that's only needed for Argo CD. I see it as something wider at the scope of the entire Kubernetes ecosystem, because it's true that Argo CD like really needs those health checks. But if I think about it, there are probably other tools in this ecosystem that would need it. I mean, someone could go and say, okay, I want to configure, I don't know, some Grafana alert, for example, when one of my resources is not healthy, or any other use cases that can be here. So this is like an ecosystem problem. And one of the attempts to bring some standards into this mess is the case status project. So basically, case status is not widely adopted yet, but case status tackles this from 2 points of view. One, it kind of recommends the authors of the custom resource definition, the authors of the controllers. It gives a recommendation which condition types should exist in the status. So it gives like a clear recommendation for those. And in a way, this can be viewed as a kind of spec. Like,
wait, this is called kube status?
Case status.
Oh, case status.
Okay. Yes.
And just so we have a, can I interrupt here? Just so people, for those that have not yet heard about case status, like it's suggesting, I believe it's 6 different fixed fields that should be on every single resource, like in the status fields. And one of them is in progress, and one is failed, and one is current, and one is terminating, and one is not found, and one is unknown. So there's like a fixed number of conditions that should be checked on every single resource.
Actually, even less, because those 6 statuses are actually what the library will be giving to you if you use the library. But the actual amount of conditions, they recommend it to be much less. They recommend it to be 2, mostly 3. Like reconciling and I don't remember, timed out or stalled. Reconciling and stalled. And so they're like clear guidelines. Again, they're not enforcing, they're recommendations. But if people follow those guidelines when they write their CRDs, then you can go and use a library which treats and can calculate those different health statuses in a generic, unified way. And
Is this actually, do people really use this library?
I don't think so,
Because
unfortunately.
it hasn't been updated in like 7 months.
it is not widely adopted, but it's like one example of an attempt that happens in the community because the need of the standard is very clear. And I think it's being used in some. Projects.
When I
So,
first
like-
heard about it, oh, sorry, that was actually from the Flux project. So I was talking to them at the KubeCon last year, and they were the one introducing to it. So I thought it was kind of new, but it's been around for 5 years. And even though it's still a great idea, very few adopters have actually been using this. And I noticed today that I was just looking through some Helm news, and I saw that this has been kind of implemented a bit in Helm 4. So I hope maybe that will help with the adoption in a way. But like, I feel like there are so many conflicting opinions about this topic, and having adoption on this is going to be a long pain.
Well, it's a good reminder that if it did require breaking changes to Kubernetes, there's this old meme guide to Kubernetes versions. It starts with 1, which is marked as useless and will never change. Then it has the minor version, but it actually breaks everything if you upgrade. And then it has a random single digit at the end that nobody cares about. So it's like if you're 1.25.6, then the only thing that really matters is the 2.5. And if you move to 2.6, it probably will break stuff. So we don't have to wait for version 2, luckily, of Kubernetes to break stuff. We can do that in the next version, which I think we're now on 35 since this meme came out. It's the old meme.
I think that 36.
36,
is either out or going to be out soon.
That's crazy. so many versions. Nice. Well, okay. But from a practical takeaway standpoint, I think everybody, like, we've kind of addressed this on a practical standpoint and a theoretical standpoint. On the practical standpoint, hey, you got to be writing these health checks, and you got to do it in such a way that it bubbles up into Argo CD. On the theoretical, a little bit theoretical, there are libraries available to help you with this stuff. They're worth checking out, though they're not probably not a clean answer. Yeah, 1.36 came out last week. Thanks for that, Standard Indian. And by the way, as we come to a close here, Standard Indian, your question about Crossplane V1 is a great one. I encourage you to bring this up in the GitOps Champions Discord. That would be a great place to post about it and get some answers. Or just post on the Argo CD subreddit if you're more comfortable there. And maybe we can do a little prep. I haven't looked at V1 of Crossplane for a long time. So I was like, oh, people are still using V1. I feel like it was a long time ago. Is it even still supported, Crossplane V1? Or is it's got to be deprecated at this point?
Basically, every company I know that uses Crossplane are still stuck on Crossplane V1 because it's such a pain migrating. At least that's what I heard.
Yeah, I think
it's an extended support.
Stick around. V1 is going to stick around for a while.
Yeah, it's an extended support for security fixes, and it does not have an end of life determined for when that will stop. Oh yeah, because so many people are stuck on it. All right, but it's been like several years that it's on V1. So good questions, Standard Indian. Please throw it into the community and let's try to get you an answer. As we come to an end here, thanks for covering these topics, Dag, Reggie, really appreciate it. Ravital, we got to remind the people, today is the last day to do the Argo CD end user survey. So make sure to get that done. We've posted about it on the Argo social channels as well as the Argo Unpacked channels. It's in this Google Forms here. We'll throw it in the show notes. Though if you're watching this after April 27th, it will be closed. So today's the last day to get that done. Coming up, we got KubeCon India coming up. We've got KubeCon China coming up. We'll have some Argo presence at both of those. We've got KubeCon Japan coming up end of July. KubeCon North America CFPs close May 31st. So you've got 1 month left to get those talks in, and then we're going to open up the CFPs for ArgoCon North America. So that'll be coming up again. ArgoCon Japan CFPs are closed. There's a whole bunch of statuses for you. Ravital, what else do we need to tell the people? You're on mute, or I can't hear you, or you're not saying anything. You're saying there's nothing to tell them.
I couldn't hear you. I couldn't hear you.
Our next episode, May 11th, is going to be all about secrets and the chaos of secrets. We're going to have Kostas Kapolonis, of course, the most popular of the Argo maintainers. Reggie might be number one on maintaining the project, but Kostas is probably number one when it comes to people getting best practices information. Not a dig, because we need you all. You're all the best. You're all the best. I love you all. Okay, let's just go it that way. Okay.
Great friendly competition.
Yeah, friendly competition. Reggie, anything else? Revital, anything else we need to close on?
No, subscribe here, argounpacked.com. You get all the previous episodes, all the upcoming episodes, shorts, links to our podcasts. We have the LinkedIn, follow us, X, Blue Sky, YouTube has a lot of great stuff, lots of good tips and shorts from those episodes.
Make sure to comment, like, subscribe, send us your tips. If you want us to cover a topic, let us know. We'd love to cover it.
Yes.
If you want Dag back to come on and talk about something else he's working on, make it happen as a community. Tell us, because otherwise we're probably not going to invite him back. But for sure, if you talk about it, no, I'm just kidding. We love you, Dag. Thanks for coming on. And as always, everybody, please stay synced.
Argo Unpacked. Stay synced.